2 weeks, 4 senior engineers, 2 of them being SMEs, one public cloud, one network, and 2 of them being solution architects, one specializing in cloud, the other one specializing in infrastructure. They couldn't figure out why a point-to-site VPN wasn't able to route to a network virtual appliance located in Azure. For 2 weeks, they troubleshooted. At long last, I got pulled in. I asked one simple question, ran a command, and shortly we were able to get it fixed. This isn't a flex. If anything, this is an embarrassment to everyone in the profession. And that's why we're making this video. And just for quick context, I've been doing infrastructure, network, and cloud for 10 years. I've been in the game for a hot minute now. And if there's one thing I want you to take away from this video, is that the fundamentals don't change. Just because you're in the cloud doesn't mean they don't apply. The problem is the cloud has trained everyone to skip these fundamentals. At the end of the day, AWS, Azure, GCP, they have all these fancy dashboards. They'll have health markers. They tell you a whole bunch of information, but they don't always show you the entire picture. They'll let you spin up resources and piece things together that don't necessarily need to be pieced together. So you have to understand the basics. Going through the OSI model, layer 1 to layer 7. You need to know how things move throughout the entire model. Otherwise, you're going to be trapped and you won't know how to troubleshoot. I'm going to show you exactly what I mean right now. So here's the overall setup, the design, if you will. We have a vendor running a third-party application here, and that vendor requires us to hide behind a singular IP address so that they can whitelist it and provide access to their application. Perfectly fine. Design around it. So here's what the architect came up with. End user remotes in, point to site, to an Azure Virtual Network Gateway. All of their traffic then gets routed to an NVA, which is sitting behind a different virtual network that is peered to the existing customer's gateway subnet, which is peered to the client's existing virtual network. NVA, which is run off a Linux VM, is doing all the natting so that any traffic that is coming from there and goes out is coming from the public IP of the NVA, which you can see right here. This is accomplished through a combination of the virtual network gateway, the peering, and UDRs, or user-defined routes. And of course, like we talked about, the vendor is going to take that public IP from the NVA and whitelist it, therefore allowing connection. On paper, as you can see, this makes complete sense. Overall, pretty simple architecture, and the traffic has a dedicated egress point. But in all reality, clearly it was complicated and nothing worked. So my coworker, again, the mid-level engineer, started working on it, started deploying all the resources, started configuring everything, ran into some problems, couldn't get it to work, escalated the issue up the chain of command, which is perfectly fine. That's exactly what we expect from them. I have no problem with that. If you run into problems, reach out to your teammates. That is 100% the right thing to do. But that's where the problems start, and that's also where I start to get some beef. It went to the Azure SME, it went to the network SME, it went to one of our solutions architects who specializes in cloud, and it also went to one of our solutions architects that specializes in infrastructure. They're looking at routes, they're looking at NSGs, they're looking at firewalls, they're recreating the NVAs, all logical steps, but no one can get the solution going. This goes on for 2 weeks. They're crazy. On paper, it's such a simple solution, so you'd think it would only take a few hours, especially coming from 4 senior engineers. So I get pulled in. I ask the situation, I ask them to show me the network diagram of what they're trying to accomplish. So they show me something similar to what I'm showing you here, and then I ask them what they've done already for troubleshooting. And they say they've done all the basics and everything that you could essentially think of. So I have them replicate the issue so I can see what's going on. And the first thing I ask is, have you ran a traceroute? See where the traffic's going. Silence. No, we have not run a traceroute. Needless to say, I was baffled. How do you know where traffic's going? How can you verify that things are actually hitting what you're trying to hit if you don't run a traceroute? So if I move on to the next diagram here, we'll see what was actually happening. User connects in to the point to site. We get to our VPN gateway, and we are reaching the NVA, but we are not getting the public IP from our NVA. We are getting the public IP from, what do you say? The NAT gateway. And if you work in the Azure space, you'll know that if you have a NAT gateway attached to a resource, if you have a public IP on the interface, it's not going to take priority. The NAT gateway is going to take priority. So we essentially have NAT gateway taking over, but even if it was working, you would have a dual NAT situation. So traffic would go out the NVA, get natted, go out the NAT gateway, get natted again. So at this point, even if it were to work in that fashion, the packets coming back aren't going to know how to get back to the source destination. So regardless of which set of beliefs you hold here, it's not going to work. So anyway, this essentially rendered the UDRs useless and the public IP useless on the NVA. And all this was discovered very simply from running a traceroute. We took this a step further. I did a traceroute from the NVA to also confirm that I couldn't even ping out from my NVA appliance directly. So then we were able to actually dig in and see what was happening. You wouldn't be able to find this just looking at the UDRs. You wouldn't be able to find this just looking at Network Watcher inside of Azure. You need to actually get in and do basic network troubleshooting. So at any rate, we fixed a few UDRs. We took out the NAT gateway, assigned a public IP on the NVA. Everything started working. 15, 20 minutes. Nothing crazy. And essentially, it's just looking at the entire topology, tracking where your packets are going, making adjustments based on what you see. At the end of the day, guys, public cloud or not, basics are basics. They apply regardless of where you're at. Routing, switching, basic troubleshooting applies regardless of your field in IT and whether it's infrastructure in front of your face or up in the cloud on a screen in a dashboard. You gotta know how to troubleshoot. And unfortunately, these modern public cloud environments, they give a lot of people excuses not to learn that stuff. They get out of college, they want to go straight to public cloud. They've never touched a switch or a router in their life. You gotta go back to the basics. And I'm sure we've all been there. I've stood up an entire data center refresh and I spun my wheels for about 2 hours because I couldn't figure out why one of my switches wasn't online. Turns out I didn't push one of the SFPs all the way into the port for my uplink. We've all been there. We've all done it. And if I followed the OSI model like I was talking about, I would have looked at that physical layer starting fresh. But we all overthink it. We all overlook it. And we go straight to level 3, level 10 of our troubleshooting minds instead of the very basics. DNS, networking, routing, plugging the cable in, all the basics that we all know and love. Anyway, guys, drop a comment below if you have a similar story or if there's been something where something crazy has happened and it was a simple fix, or maybe just a cool story that you helped save the day on. Also, guys, don't forget, it's Read Only Friday. Don't push any changes out. Like and subscribe if you want to see more content like this. Peace.